Hi, and welcome to this demo. This presentation is brought to you by Georgia Tech's OMSCS Software Architecture and Design course CS6310. My name is Josh Mitchell, representing the excitingly named Team A7-14. The dash is very important. The team is also made up of Sean Rule and Tim Aaron. Three main things we want to cover on our agenda today. The first is the design changes that were made in response to the specification changes that were given to us in later assignments. We'll go over those four main changes that we made. Next is a brief covering of the downloading and running of the virtual machine. We want to make sure that the TAs are able to get in and run our project. And then finally, an application demo in which we will talk about the efficiency of our project, show how to run it, and go over the log files. All right, so the first big change that was made following the specifications that were given to us was the implementation of a broker that acts as a monitor between the simulator and the mowers. And so this was to avoid potential, quote, cheating situations where the mowers know things they're not supposed to know. And so to make this more viable and easy for maintenance purposes, we implemented this monitor, which essentially uh, acts as an interface between the simulator and the mowers and validates the actions that the mowers take. The next major change that was made was the mower synchronization, which is the shared communication channel between all the mowers. And the way we did this is that each mower registers with a manager data structure called the mower lawn map communication. And this manager is implemented using a weighted graph data structure. And the way the weights work is that there is the weights are essentially the relative offsets between where the mowers start. So each mower thinks that it starts at 0, 0. And so the weights are those relative offsets between them. Now, how this data structure is populated is that as mowers move, as the turns occur, the simulation asks the mower for what it wants its next move to be. Now, the mower responds by reaching out to the communication manager and asking for that updated um, map, essentially. And so this is based on each mower providing information to that broker, or excuse me, to that data structure. And as the mowers reach out and ask for that map, they're then able to make better decisions about the overall um, map. And especially as the map grows or as the mowers spread out, they're able to even have more information about what the overall map looks like. Okay, the next major change was the energy management, and each mower, of course, can now run out of energy. And it starts by each mower registers a energy pad, its own energy pad. And then as it moves about and it sees through scans other energy pads, it registers those as well. Now, each mower also keeps track of the relative distance between each of those energy pads so that it knows which one's the closest at any given time. Now, the mower then, before or after a move, um, it recalculates how far away it is from that energy pad and compares it to how much energy it has. And then there's a certain threshold at which it says, okay, I need to start moving back to the energy pad um, and make sure that I have enough energy to get there. The last major change that was made was the implementation of a GUI. We did this using Java X. We implemented it in a very decoupled way. We exposed the simulator class APIs as like an API so that the GUI controller class could just reach out and call the necessary functions in order to control the simulator. But because of the decoupling, we were able to actually just still use the simulator directly through IDEs or through the command line, however we wanted to do it. So this decoupling approach worked out really well for us. Okay, and now for a quick demo. All right, so the first thing is that if you're reading this or if you're watching this video, you have our README, and in there is a link to download our 1 GB OVA, and just download that. It'll take about 15 minutes on a fast internet speed. So the first thing we need to pull up now is the actual VirtualBox. So you run this from VirtualBox, and when you go to run this, you may get an error about USB. So if you get that, just go to the USB and set it to 1.1 or install the extension pack. Okay, so the next thing is to actually go into, I've already got it up and running, of course. And so the password is the same as the username, osboxes.org. Make sure I type that in right. Okay, so the first thing you'll see is this is the jar file of our compiled program. Here are the test scenarios that we'll be running, and here's the run sim shortcut. To kick off the application, double click this run sim. When it opens up, it will first start by prompting you to go and pick a file. So go to the desktop, go to the test scenarios. And so we have all of our different test files we used, but for this, we're going to use one of the ones that were provided to us, the test2, which is the easiest. Select that. Okay, so you can see here that there are 4 mowers. This one's facing east, this one's facing east, this one's facing east, and so on. Okay, and then you can see the grass is displayed here with these squares, and then here are the craters and the energy. And we pretty much followed what was in the design documents. And over here are the stats. You have the size of the lawn, how many squares were cut, grass remaining, turns taken. And then the mower that is going to be running, about to take its turn, it's highlighted in bold. So let's run through by just pressing the play button. So you can see over here, change to this mower. Press it again. You can see it's continuing to change. And I'll just click it a bunch of times. You can kind of watch the action take place. All right. Okay. So the next thing I want to point out is that we're just going to jump through. All right. It ran to completion. And you can see that this one completed successfully, completing all the cuts. We just had one more run out of energy. Okay, so to run another file, just close that out and open the sim again. And this time we're going to pick a harder one. This time we're going to pick this one here. This is the hardest one. It has, I believe, 6 mowers. Yeah, and it's quite large grid with some really challenging scenarios. So we're going to just run this to completion. Okay, and you can see that it completed most of it. I think it's about 88% of it was completed. And what happened is all the mowers ran out of energy. And so the reason for this is we found out that there's the mowers would oftentimes get stuck. Getting back from a situation like this, getting back from these various situations could be really difficult. And so, but we also found that the general strategy we had worked really well for the mowers to be able to cut like most of the grass. Okay, so let's take a look at the output files. So those can be found in the home directory. So if you go to the home folder, you can see here the 2 reports that were run. So I'll open up this one here, and you can see that each of the mowers, mower 1 scanned, and you can just see that the output is according to the standard that was provided to us in the document. And so we'll jump down to the very bottom to look at the summary. You can see here that we completed 96 of the 108 grass squares in 106 turns. And that is pretty much it. We're out of time. The other things to point out would be that we did have 4 design documents. There is a deployment diagram. There is a use case diagram. There is a extensive sequence diagram, as well as a very detailed class diagram, all of which kind of tell more about our design. And that pretty much sums it up. We're excited to get feedback and see what people thought about our implementation. Thank you.